Hey, everybody. It's been 7 years since any new data has been gathered in the search for MH370. It was back in the year 2017 that Ocean Infinity announced to everyone's surprise that they were willing to, on their own dime, extend the seabed search beyond the 120,000 square kilometers that had been scanned under the auspices of the Australian government. Ocean Infinity scanned another 180,000 square kilometers. They found nothing. Periodically since then, there have been murmurings that Ocean Infinity might take up the search again. They might extend the search area. Just this past March, there were numerous news articles published saying that Ocean Infinity was on the verge of an agreement with the Malaysian government and so forth. Nothing ever came of it. Australia has made clear that they have no intention of spending more taxpayer money on this project. Now, periodically, I still see pleas from people, especially relatives of the missing, begging and pleading for the search to be restarted. The idea that a lot of people have accepted is that the plane must be on the seabed. And so the only way to solve the mystery is to extend the search on the seabed. I think I've made the case in this podcast that it might not be on the seabed, and we need to keep our minds open to other possibilities. What other ways can we solve this mystery? What other gaps or loose ends in the evidence can we explore and try to make sense of? That's a question I've been asking myself for 10 years, and now I'm ready to take my shot. Today, I'm very excited to announce a project that will get the first new evidence in the mystery of MH370 in 7 years. And I think it just might lay the whole case to rest. But there's a catch. I'm going to need your help. Hi, guys. Very excited to be back with you for today's episode. I'm going to tell you about a project that I'm launching this coming Tuesday that I think could really change the nature of the game. In fact, I think it's important enough that I want to do something that I have never yet done before, which is to have an open live video call in case anybody has questions or suggestions or comments. This is going to have to be a collective effort. If we're going to do it, we're going to have to do it together. And so I want to be as open and inclusive as I can be. My plan is to have a Google Meet call at noon Eastern Daylight Time. That's New York time. I'm going to put a link in the chat section of the show page. There's a link here. I'll put a link in there a couple hours before the start of the talk, and just check out the link there. Think of it like office hours. You can pop in and ask a question or leave a comment or just say hi. Okay, so let's get into the heart of the matter. I really want to tell you about the experiment that I'm launching. It's called the Finding MH370 Project. It will put a real 777 flaperon in the southern Indian Ocean and then monitor how Lepus barnacles grow on it. We have found a source for the flaperon. We have a source for the telemetry, and we have a research organization that is going to put it into the ocean for us. All of the pieces are lined up. All we have to do is pay for it. So I started a Kickstarter. Here is the link. The project will go live on Tuesday, October 1st, 2024. But you can click before then on the Notify Me on Launch button. That actually would be incredibly helpful. Without even having to pledge any money or anything, just clicking on that notification is good. All right, let's talk a little bit about the project and why it could change the course of the mystery. Those of you who have been following along for the last few episodes have heard me talk about the paradoxical nature of the debris that washed ashore in the Western Indian Ocean, starting on Réunion Island and then elsewhere. There were two major paradoxes. First, the barnacles were too small. We went into this in great depth in season 1 The upshot is that barnacles grow at a certain rate in a given body of water. And although we don't have a lot of data for the southern Indian Ocean specifically, based on a boat that washed ashore on Mayotte just around the time of the plane's disappearance, actually, the barnacles on the flaperon should have been substantially larger than they turned out to be. That implies that those barnacles, and in fact, every other piece of debris that washed up, there seems to be about a year-long gap between when the pieces went in the water and when marine organisms started to grow on them. The second problem is how the Lepus barnacles were growing all over the flaperon, over the entire surface, even on parts that were sticking up out of the water. This problem was known from the very beginning, from when French investigators took the piece to Toulouse, they put it in a test tank, and they saw that it floated high out of the water, even though the piece was totally covered in barnacles, suggesting that it had floated totally submerged. And that's a puzzle that no one has ever been able to explain. But we're going to change that. The Finding MH370 project is going to come in two parts. The first part is one that we've already started. We talked about this in episode 16. That is the effort to collect Lepus specimens from some of the numerous global drifters. There's over 1,200 right now floating around in the various oceans. They all have marine debris. Well, sorry, they all have marine organisms living on them. And so in order to get a sense of how Lepus antitifera should grow on pieces that drift across the southern Pacific Ocean, we want to take samples from these buoys and basically develop a robust data set showing how they grow, how fast they grow. And then we can compare that to what we see on the MH370 debris, especially the flaperon. This will be an ongoing project. We've already started it. We're going to probably keep doing it after the whole flaperon part. The second part is to acquire a real flaperon and put it into the southern Indian Ocean. And let me address the question of why we have to get a real flaperon. And that is simply that if we make a replica, no matter how realistic it might seem to us, people might not accept the results of the experiment. They might say, okay, well, what you built was not quite the same. You can't generalize from the experience of this thing you built to the actual flaperon, so the results are invalid. And we've sort of have a precedent for this, actually. You might remember that when Australian officials of an organization called CSIRO, which stands for Commonwealth Scientific and Industrial Research Organization, it's basically a state scientific research body of the Australian government. And they were tasked with figuring out where the flaperon most likely drifted from, based on their assessment of known ocean currents and so forth. When they plugged the data into their model, they were not able to get it to work. They couldn't figure out how the flaperon could have drifted from a presumed crash site near the Seventh Arc all the way to Réunion Island in 15 months, in a year and a quarter. So they thought, okay, there must be a wind factor. Things drift faster if the wind is pushing them, and the more they stick up out of the water, the more windage they get. So the scientists at CSIRO built a replica flaperon, and they put it in the water, and they measured how it was affected by the wind, and they still couldn't get their drift models to work. And they were very frustrated. And they thought, well, we really want to get this nailed down. And so they were fortunate that the NTSB, the American accident investigation body, gave them a flaperon from a 777. They cut it down to match the damage seen on the Réunion flaperon. They put it in the water. Lo and behold, the wind pushed it in a way that made their models work. They could finally understand how this piece could have gotten all the way across the ocean in that amount of time. So that goes to show that, first of all, that this kind of project is possible. They've done it already. And secondly, that you really do need the real thing if you want to get results that really mimic what a real flaperon would do. So that's what we're going to do. We're going to try to go whole hog, get a real flaperon, cut it down the same way the Australians did, put it in the ocean, and hopefully, just as they found with their flaperon, that it will behave in the same way that this piece of debris would have behaved. Okay. When I started out with this idea of getting a real flaperon, I had no idea, first of all, where you get a flaperon, and secondly, how much it costs. So with Keely's help, actually Keely did pretty much all of the work at first, especially. We called around and after a lot of work, actually, we kind of had to break into this whole new field we knew nothing about. And we found some people who were willing to sell us a 777 flaperon. And this is what they were asking. One potential supplier wrote, if the unit is in good condition, it could be worth about $200,000, and we can sell it to an airline. However, if we are unable to get it back to serviceable condition, then it will be something we can sell as is for a much lower price. Okay, much lower price. That got my attention. But how much? So we asked around some more, and one wrote, we have located a right-hand flaperon from a B777-200. Pricing would be US dollars $44,000. Another wrote, we have the part number that we can sell with a fresh SVC tag for $45,000. Lead time around 25 to 30 days. This was not looking good. That was a lot of money. I mean, I don't know what I thought they would cost. I really had no idea. I sort of imagined maybe $1,000, $4,000, something like that. There's a lot more than that. But then we heard from a company called eCube in the UK. Their rep, Sergey, wrote, I can confirm we do have a B777 flaperons available at eCube UK. Component, blah, 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 from Boeing 777X200, ex-British Airways. We are quoting these at $24,000. Okay. Well, that is a lot of money, but look, this is going to be a significant undertaking. I don't think at this point that we're going to be able to do any better than that. I think $24,000 is what we're going to be talking about. If we want this thing to happen, that's what we're looking at. Okay, so what else? What other costs? What about shipping? Sergey wrote, air rate US dollars $2,650, $2,650. Transit time approximately 5 to 7 days. By sea, it's only $1,950, $1,950. Sailing time 36 days. Okay, I don't know if we have time for that. So now what else? So we're looking at $27,000 just to get it out the door. As you may recall from episode 12, we talked about this idea with Andy Sabrandi of Pacific Gyre, the company that makes all the drifter buoys telemetry. And we discussed it with him, and he offered to equip it with telemetry. I asked him how much it would cost, and he said it will cost at most $5,000 to complete the project. And then maybe another $3,000 to get it to the port where we're going to put it aboard a ship. That gives us a total of about $35,000 so far. Now, if I'm going to raise this money through Kickstarter, they're going to charge 5% plus a payment processing fee of 3 to 5%. So let's call that 10%. Rough and ready, let's say that the scale of the project we're looking at, we're going to look at $5,000 off the top from Kickstarter. So we're looking at $40K. 40,000 US dollars. And we haven't even gotten this thing in the water yet. Last week, I had a really excellent phone conversation with OceanX, which is a marine exploration nonprofit that runs a ship called the Ocean Explorer. And in January, as fate would have it, they're going to start an expedition from Singapore out across the Indian Ocean. And they verbally offered to deploy the flaperon for me. If they do, that's going to be a huge savings. And hopefully we'll be able to bring the project in significantly under enough budget that we can use some of the other money to help collect more drifter buoys in the first part of the experiment. Fingers crossed. There's not a lot of wiggle room, frankly. But I think we can get it done. And basically we have to, because Kickstarter discourages you from trying to raise more than $50,000. They basically say you can't do it, or it's very rare that it gets done. So this is the plan I'm basically looking at. The Kickstarter goes live on October 1st, that's next Tuesday, and closes on October 30th. If it's successful, we buy the flaperon that eCube had set aside for us, and we ship it to the Pacific Gyre in California, and it arrives mid-November. Andy takes a month to outfit it with telemetry, and he forwards it to Singapore, where it arrives by the end of December. Gets loaded onto Ocean Explorer, which sets sail around January 8th. And then hopefully somewhere in the general vicinity of March 8th, the 11th anniversary of the disappearance, it gets deployed somewhere near the 7th arc. Now, I should say that if we get as far as all that, I'm not that concerned that it goes exactly in the water on March 8th or that it goes exactly on the 7th arc. And the reason for that is that there are many unknowns, but the unknowns don't matter that much. Lepus antitifera are cosmopolitan organisms, meaning they grow in a wide geographical area. They are tolerant of a wide range of conditions. They grow quite happily, anywhere from 18, 19, 20 degrees Celsius up to 30 degrees Celsius. The temperature matters. I think the nutrient level in the water matters. And I think a body of water like the South Indian Ocean Gyre is different from the North Pacific Gyre, which is different from, say, tropical Pacific. But I believe that if you're in this kind of general body of water, conditions are rather similar in terms of nutrient density because things get swirled around a lot. So if you're anywhere within like a 10-degree band and a 10-degree Celsius band, I think you're looking at more or less similar conditions. We will be able to test that by looking at the drifter buoy data in the first part of the experiment. If we see that a buoy that drifts at 10 degrees south latitude has Lepus barnacles growing at a radically different rate from one at 20 degrees or 30 degrees south latitude, then we've learned something. I suspect that the result will be that we can put this thing in the water in a fairly wide range of latitude and water temperature conditions, and you'll get similar results. So we've put it in the water. Over the following 15 months, we're going to be able to follow its progress across the ocean because of the GPS signal that it's going to be sending. Drift is very random, so the chances that it winds up anywhere near La Réunion is very, very slim, vanishingly slim. But it will be in the same ocean, probably similar temperature. Lepus are fairly robust, as I said, and so I think what happens will be illustrative. We'll be able to watch, depending on the exact instrumentation that Andy puts on it. My expectation is that we will have cameras trained on the surface, both above and below the presumed waterline. We will be able to see how and if these things are growing. We won't probably be able to measure the exact dimensions, but we will be able to see if they grow all over the whole surface, which is really the main purpose of this experiment. And then after 15 months, we're going to try to retrieve it. We would like to get the actual Lepus barnacles and even ideally do chemical analysis so that we can correlate the mineral content versus the temperature that we've retrieved through the telemetry. Retrieval is going to be a difficult and potentially expensive part of the mission. Maybe I shouldn't spend any money until we try to retrieve it, because that might be a killer right there. I would love to try to get, if we don't actually pull the thing out of the water, I would like at least to scrape off as many barnacles as we can. We'll have more to say about that later. But even if we can't get it, the cameras will have allowed us to answer the main question, which is, do lepus grow above the waterline on a drifting flaperon? The answer to that question will be either yes or no. It'll be binary. If we see that lepus don't grow above the waterline, then that implies that there's something fishy about the flaperon that was retrieved on La Réunion. If we see that for whatever reason, maybe splashing water or the piece flipping or whatever it may be, if lepus do grow above a waterline, if there essentially is no waterline, then the reverse will have been demonstrated. That actually it is quite reasonable that this thing floated from the seventh arc, and in fact, probably does imply that the plane did go into the southern Indian Ocean. We'll be able to cross-reference those results against our findings from the other part of the experiment, where the question is, do lepus growing on objects in the southern Indian Ocean consistently grow larger than the 3.6 centimeters that they were seen on the flaperon on La Réunion? If the answer is yes, if they do consistently grow bigger than that, this suggests that the flaperon did not get to Réunion by natural means. If not, then maybe it did. Probably it did. Of course, there's then a third possibility, which is that these two results contradict each other or are not in agreement with each other, in which case we're still confused. But that's science. You don't know what the results are going to be when you start your experiment. Otherwise, it wouldn't be an experiment. Okay. Now, I should add that while I was thinking about putting this project together, it occurred to me that, in a sense, I was reinventing the wheel. CSIRO had already done this same thing. They had taken a real flaperon, cut it down, and whatever happened to that flaperon? I mean, is that still around? So I reached out to CSIRO and to Dr. David Griffin, the physical oceanographer who oversaw the flaperon project, and he wrote back to me right away. This is what he said. I got this email actually about 12 hours ago. He wrote, "Hello, Jeff. I've checked with our store manager who said that the flaperon was disposed of a few years ago. So sorry, we can't help you." Crap. "I would have liked to do the study you proposed, but decided against it for a number of reasons. Namely, one, how would you retrieve it? A trip out to the Indian Ocean is not cheap." That's an excellent point. I do think we have a way around it, which I will discuss later. Two, if its path was very different to the MH370 one, the results are not much value. I'm not so sure about that. I think if it floats far to the south and gets into cold water, then yes, we're going to be out of luck. But having looked at how these things, I've been basically camping out watching the NOAA website where you can track these things, and they really don't usually go very far. I think if we put it fairly far to the north, at the sort of northern end of the search area, I think there's very little chance it's going to get into cold water in a reasonable time frame. I think we will get good data. And then Dr. Griffin's third point, how would the findings affect a future search anyway? That's a more sort of philosophical question. I think that Dr. Griffin, like most of the Australian establishment, assumes that there's a 100% chance that the plane went into the ocean, that its wreckage is somewhere on the seabed. I don't think he seriously entertains the possibility that something is fishy. And I think that was, he doesn't mention this factor, but I'm kind of interpolating. I think that he doesn't think that this experiment will get interesting results. Namely, I think that let me read the rest of what he said. "When we did our field tests of the flaperon, we saw it flipping over when the wind got up. I assume you know that and have seen the footage. I have. I figured that this explained why the lepus colonized many sites near both the trailing and leading edges." I've talked about this before, but I think flipping is not enough to explain the existence of lepus on the trailing edge, because the trailing edge is never submerged, no matter which way it flips. Okay. Finally, he wrote, "The follow-up study I came closest to doing was a, quote, soak test. put the flaperon in seawater and see how much freeboard it lost over time. But again, I didn't think the learnings would have enough impact. And it was surprisingly hard to find somewhere to conduct my study. I nearly used my own dam on my farm. Good luck, David. Well, that's interesting, actually. I mean, I didn't realize to what extent he did find the condition of the flaperon puzzling enough that he wanted to conduct some experiments like this. And I appreciate him getting back to me so quickly. So that was extremely useful. It sucks that he threw it out. I mean, I'm tempted to write back and say, like, what landfill is it in? Can we go dig it out? But I mean, I don't know, what does one do with a used flaperon? I mean, these things are not small. At any rate, let's keep with our plan. I've got the Kickstarter, starting next week. If you would like to see this experiment take place, please join in. Any amount, even $1 would be great. If you can do more, obviously that would be amazing. My hope is that if word gets out, a lot of people can give a little bit of money. We can not only get this thing done, but we can do it as a collective action. I'd much rather have 1,000 people give $5 each, or 50,000 people give $1 each, than have like a couple of rich people come in and do it for us. This case belongs to us. It belongs to all of us. This mystery affects everyone. It would be really great if everyone could kind of come together and work collectively to solve it. When the Australians funded the seabed search, it was hundreds of millions of dollars of Australian taxpayer money. It was very much a top-down effort. For a fraction, a tiny, tiny fraction of that, we could really move the needle, get some answers to one of the mysteries within a mystery that is so characteristic of this case. And when you drive down the road here in the US, a lot of the cars you're passing each cost $50,000 or more. So I think that we collectively as a society can surely allocate that much of our collective resources to solving what is really undeniably a gaping hole in our understanding of the most important mystery in all of aviation. And listen, it will be highly entertaining to watch this thing day after day as it drifts across the ocean and grows its little community of barnacles. It'll be like watching my tomato plants in the spring, except with world historical ramifications. Okay, that's all I have to say to you about this for now. Please do go over to the Kickstarter and click that notify bar. In the meantime, I'd like to express my heartfelt gratitude for the volunteers who've helped with the research, especially Keely, Ben Cornelius, and Rochelle Reynolds. Thank you as well to all the members of the community who have supported this podcast with paid show page subscriptions and YouTube memberships. And if you have anything you'd like to say or ask, please come visit with me on Sunday, noon Eastern US time. I'll put a link to the show page comment section. Until then, don't stop looking and don't stop asking hard questions. See you soon.